Hi there. In the previous video, we learned how to convert a standard form of a circle into its center radius form. For this one, our goal is the other way around. That is, we convert a center radius form of a circle into its standard form. So that is what we're gonna do in this video. To do this, our strategy would be to use the square of a binomial. So if you don't know what the square of a binomial is, I can probably link a video on about this one out here. So let me check that one out. If you don't want to, here's a brief description on what it is. So if we have a sum of a binomial and we square that one, the outcome is given by the square of the first term plus 2 times the product of the first and the last term plus the square of the last term. So this is the form of its square. Similarly, if we have a minus b and we square that one, the outcome would be the same or similar to it. The only change is in the middle term. So we'll have here subtraction instead of addition. So the reason that we'll be needing this one is because in center radius form we have x minus h squared and y minus k squared. So we'll be needing this concept in order to expand these square of binomials out here. So yeah, now that we know this one, let's now try out some examples, starting with the first example. So we have x plus 1 squared plus y plus 2 squared equals 27. Before we convert this to the standard form, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So let us first apply the square of a binomial in this first binomial out here. So we'll have the square of the first term, which is x squared, plus 2 times their product, plus the square of the last term. So we didn't need to put the square out here, since 1 squared is just equal to 1. So we don't really need that one. After this, let's go on to the next binomial. So squaring this, we'll have y squared plus 2 times their product, plus the square of the last term, which is 2 squared. And just bring down the equals 27 out here. From here, for the first group out here, we can simplify this one, since 2 times x times 1 is just 2x, so we'll have x squared plus 2x plus 1. For the next one, take note that 2 times 2 is equal to 4, and 2 squared is equal to 4. So given these, we can now simplify this one, so we'll have y squared plus 4y plus 4. And just bring down the equals 27. Now in here, take note that we can add 1 and 4 out here, and aside from that, we can move 27 to the left, since take note that in standard form of a conic section, we have ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So one side of the equation is 0, and every other terms are on the left side. Moreover, we won't really be needing xy out here in circles, so we can disregard that one. And so we have this. So what we're gonna do is we will be rearranging this equation of this form. So the squares go first, then the linear or variables of degree 1 goes after these two, and lastly the constant. So doing that, we'll have x squared plus y squared, the degree 2 terms, plus 2x plus 4y, the degree 1 terms, and the constant, which is 5 minus 27. Simplifying 5 minus 27, and we'll have this. So the final answer is given by x squared plus y squared plus 2x plus 4y minus 22 equals 0. This out here is the standard form of the given center radius form. So I hope you got that one correctly. Let's now move to the second example. We have here quantity x plus 3 squared plus quantity y minus 2 squared equals 81. Again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. Similar to the first example, we start by applying square of a binomial in this first one. So we'll have x squared plus 2 times their product plus 3 squared. Next, for the second binomial, we have y squared minus 2 times their product, y times 2, plus the square of the last term, which is 2 squared, and brings down the equals 81. Never forget that one. Now let's simplify these groups out here. So for the first one, take note that 2 times 3 is equal to 6 and 3 squared is equal to 9. For the next one, 2 times 2 is equal to 4 and 2 squared is equal to 4. So given these out here, we can now simplify this equation. So we have here x squared plus 6x plus 9 plus y squared minus 4y plus 4 equals 81. And again, like how we did a while ago, we first start by adding these constants out here and moving the constant on the right to the left side of the equation. Aside from that, we rearrange this equation to our desired one. So we'll have here x squared plus y squared, again the degree 2 terms, plus 6x minus 4y, the degree 1 terms, and the constant 13 minus 81. Simplifying 13 minus 81, and we get this one. So we have x squared plus y squared plus 6x minus 4y minus 68 equals 0. This out here is the final answer for this problem. So we had successfully converted the center radius form into its standard form. So I hope this one is clear. Let's now move on to the last example. In here, we have quantity x minus 5 squared plus y squared equals 36. And again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's work on this one. So we start again with the first binomial. Well, actually, there's only one binomial out here, which is x minus 5 squared. Aside from this, to save a step later on, we can move 36 already to the left. So we'll have x squared minus 2 times their product, x times 5, plus 5 squared, plus y squared minus 36 equals 0. Simplifying this one out here, so take note that 2 times 5 is equal to 10 and 5 squared is equal to 25. So this simplifies to x squared minus 10x plus 25 plus y squared minus 36 equals 0. Take note that we aren't really doing anything with the y squared out here since it's already in the simplest possible form, since it is not a binomial in this case. Basically, this just tells us that we have here y minus 0 squared. And if you try to apply the square of the binomial, the outcome would still be y squared. since some of the other terms will just have 2 times 0 times y and 0 squared, which is just nothing, which is just value, which just results to 0, I mean. So just to take note of that one. And similar to our first 2 examples, in here, take note that we can add 25 and negative 36, so the outcome would be negative 11. So given that, again, rearranging some of these terms to our liking or to our desired outcome, we'll have x squared plus y squared minus 10x minus 11 equals 0. Since this is already the simplest form, we can't really do anything about it, we conclude that this one out here is the final answer. So we converted the center radius form out here into its standard form. And so that is how we convert the center radius form of a circle to its standard form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So to formally end this, here's an exercise that you can work on. So here we have 4x squared plus 4 times y minus 7 squared equals 1. So the idea is same out here, but might be harder a bit since we'll actually start here by dividing 4 on all sides. Then, since we have 4 out here, then after that, we'll do the same process with our examples. It will just be a bit problematic since we'll have fraction out here, 1 over 4. And you need to be careful in adding and subtracting some of the constant terms out here. So yeah, I hope you enjoyed and learned a lot from this one. Feel free to comment down below any suggestions and recommendations that you have for this video and this channel in general. And also, if you have a solution and answer to this exercise, please don't hesitate to comment it as well down below. So yeah, that's it, and that's all for this video.